I'm going to lump together our next two assumptions because they're both related to residuals. Now remember that residuals are about the sample that we've taken, and they are the difference between y and y hat. Y being our actual value and y hat being our predicted value based on our regression equation. And for the population, that's prediction error. But for our particular sample and our regression equation of interest, that is the residuals. Now, if we just do a simple bivariate regression, we plot the scatter plot, it looks something like this. Right? And these are our actual values of y, and then this represents the expected value of y. Right? Now, the difference between each of these is the residual. We make two assumptions related to the residuals. The first one is that the residuals are normally distributed around the mean, right? And while if the residuals are not normally distributed, this can cause us problems. The estimate, this is kind of a weird one, the estimate is still probably okay. So our estimate of our parameters is probably okay. In other words, it's still going to be blue. It's our best linear, unbiased estimate. So the estimate itself is going to be linear, it's going to be unbiased, it's going to be the best one that we can get. The problem is not with when we violate the assumption of normal residuals. The problem is not with the estimate, it's with the standard errors of the estimate. In that case, the standard errors, when our residuals are not normally distributed, is what we call ill-behaved. In other words, the p-values are a mess, so we don't really understand what they mean. And in fact, typically, this means that the test will be underpowered. So we may get a good estimate of our parameter, but we will not be able to really test whether or not that parameter is significant because the p-values are going to be ill-behaved. Our other assumption here is that the mean of the residuals is 0. Right? So we should see about the same number above and below our expected value of y. The mean is 0. So obviously some are going to be above, some are going to be below, but altogether they should average out to about 0. And again, what this means, if this is not true, if the means of the residuals are not 0, that again is a sign that there's a missing variable. That's a sign of endogeneity, that there is a missing variable somewhere. So for instance, not including an interaction. That's usually where this comes from. If we find that our residuals are something other than 0, usually that happens because there's an interaction variable. So that's something we may want to check for that may give us a clue that there's an interaction someplace or that we should be considering x squared instead of just x.